All right, so let's look at this one. What is happening here? The first one, yeah, is a cubed. Well, it's a cube. How do we find? Oh, it's not a cube actually. It's a. If you look at it, there's a 3-inch here, and that's 2 inches, 2 inches. So it's not a cube. This is something called like a rectangular prism. How would we find the surface area of this? Notice it has 6 faces, right? So how would that work in this case? We just add up all the 6 faces. So let's look at the front face. What's the area of the front face?
6.
Yeah, 6. 6, and then 1 is in the front, 1 is in the back, yeah? So 6 times 2. So that covers the front and the back. Let's do left and right, like this one and this one. What would it be for that? Any ideas? What's the area of the side faces, basically, is the question.
Is it also 6?
It's not 6. It is not 6, right? We know this is 2. What's this? What's the length of this? It's not 3.
2.
2. So if that's 2, then this is 2, and that's 2 as well. So the left and the right, you see these? It's going to be 4 each. 2 times 2. 4 times 2 for left and right. What about up and down?
6.
Yeah, 6. And there's also 2 of them, right? So what'll be the answer here? 6 times 2, 12, plus 8 plus 12, 32. And we're looking for the surface area, so it's going to be inch squared. Does that make sense? So we're just adding up the faces of the shape. What about the volume? If that's the surface area, what would be the volume of a rectangular prism? What's the volume of a cube? It's pretty similar to that. The volume of a cube is length cubed, okay? L cubed. The volume of a shape like this, it's gonna be length times width times height. What's the length? We know the height is 2. Okay, length, it doesn't matter. Actually, you can say this is the length, 3, or you can say 2 is the length. It doesn't matter. We're gonna say 3 is the length and 2 is the width. Okay, like that. You see this? So 12 inch cubed, and you're done. Okay.
Okay.
An easier formula for volume to remember, and this is gonna work for every shape, is its base area times height. Okay, base area. What's the base area here? 3 times 2, 6 times 2, and that's gonna give you a 12, right? So that's how you find the volume. And that works for everything except a pyramid. For a pyramid, you have to do base area times height divided by 3. I guess we'll see if we ever encounter a shape like that. So the name of shape number 1 is a rectangular prism, okay? Let's look at 2. What do you think the name for this one is? And it's certainly not a pyramid.
A triangular prism?
Yes, a triangular prism. So let's first find the surface area. Now notice there's only 5 sides. Before in our rectangular, we had 6. Here we only have 5 sides. So let's do the front and the back. What will be the area for the front face? The front face is a triangle, correct?
mhm.
What's the area for formula of area of a triangle?
Base times height over 2.
Right, base times height divided by 2. So 2 times 2 divided by 2. That's the area of the front face, right?
Mhm.
And then there's 2 of them, the one in the front and the back. So we've dealt with the front face and the back face. The back means this one. Now let's look at the left and the right. What will be the surface area of this face here? That's a rectangle, okay?
So 2.2 times 4.
Yeah, 2.2 times 4. And there's 2 of them. There's one on the right and then the one on the left. Yeah.
Mhm.
And then there is a face on the bottom. There's just one singular face on the bottom.
2 times 4.
2 times 4 indeed. 2 times 4. Now if you plug this in the calculator, you get 4 plus 8.8 times 2 plus 8. What's that? 12 plus 4 plus 2.2 times 4 times 2 plus 8, and that gives us 29.6 inches squared. Okay, the area for
Mhm.
the unit for area will always be squared. Now that's a surface area. That's pretty easy. Right? You just add up all the surfaces. What about the volume of this shape? What do you think for the volume of this shape? Now the question is, right, the formula for volume of any shape is base area times the height. Okay,
Mhm.
it's a base area times the height. And when you think of base areas, it is going to be the side that repeats. What do I mean by that? The base is not 8. This is not the base because it does not repeat, does it? See the bottom
Mhm.
face? It never repeats. But the front and the back face that repeats, yeah? This
Uh-huh.
face and this face that repeats. So this shape is actually like something like this. Okay? Where
But
these are the
couldn't the
bases.
2 rectangles be the base?
The ones on the sides?
Mhm.
No, they're not symmetrical. They're kind of making a triangular shape.
Oh, okay.
The base should be identical, okay? If you look at the left triangle, it's going inward. Like one is going this way and one is going this way, okay?
Mhm.
So that's probably not the base. And in the bottom one, it doesn't repeat, so that's not our base. Our base is gonna be the front and the back side.
Okay.
A better way to do this actually is something called the cross-sectional area. This is the technical term. The volume of any object is the cross-sectional area times the height. Now let's look at what cross-sectional area is. Think this is a loaf of butter, okay? And we're gonna
Mhm.
cut this with a knife. Okay, if we cut this with a knife, what do we get? We're gonna get one face like this and then another face like this, yeah?
Mhm.
You see, this is the cross-sectional area. You chop it, and the face that you get is the cross-sectional area.
Mhm.
In this case, if we were to chop it, we would still get the front face, so we didn't need to do this. But think about a spear, like a 3D circle. If we chop this, what would be the cross-sectional area?
The circle,
Yeah, good. It's gonna be the circle. What's the height of this thingy?
the diameter.
Right, it's gonna be the diameter, right? So the cross-sectional area is a circle for this guy, okay? For
Mhm.
us, for this shape, for the triangular prism, the cross-sectional area is the front face. So the volume is gonna be the volume of the base, which is a triangle, this times the height. So that's 4 over 2 times 4, 16 over 2, it's 8. 8 inches cubed, and that will be the volume. Does that make sense?
Uh-huh.
Just remember, it's cross-sectional area times the height is the volume. Let's look at 3. What's the shape?
A cylinder.
A cylinder. What's the surface area of a cylinder? So we have 2 circles on the top and the bottom, right?
Do you find the circumference of a circle?
Yeah, that's exactly what you do. So why do you do that? How does that help us?
Because if you open it up, like it's a rectangle and two circles.
Yeah, exactly. So if we open it up, we would get something like this, right?
Mhm.
So this, the length of the rectangle would be the circumference. So what's the radius in this case?
7 divided by 2, so 3.5.
Exactly. Radius is 3.5 inches. What's the formula for the circumference of a circle?
2 pi r.
Yeah, 2 pi r. So we can just plug this in the calculator. 2 pi times 3.5, and that's 22 inches is the circumference. Now what do we do? What's the surface area?
22 times 6
Yeah, that'll
would
give
be
us,
the rectangle.
yep. And then,
And then you find the area of the two circles.
yeah. So 2 times, what's the area of a circle?
Pi r squared.
Correct. Pi r squared, like that.
Times 2.
Yeah, I already did that here in the front.
Oh, okay.
Does that make sense?
Mhm.
So we have 22 times 6 plus 2 times pi times 3.5 squared. That gives me 209 inch squared for the surface area. Cool.
Mhm.
How do we find the volume? And again, remember, volume is going to be the base area. And base will be like if you take a knife and if you chop it, that'll be the base.
So the area of a circle times the height.
Yeah, exactly. So 2. Actually, we don't need the 2 because we don't have 2 circles anymore. So it's just going to be pi r squared would be the circle times the height, like that. And that'll be the volume of this shape.
Mhm.
That's 231 inches. What's the unit for volume?
Cubed.
Yep, and there we go. That's the final answer for this, okay?
Okay.
Got 4. What's the shape?
Um, a triangular prism.
Yes, so let's first find the surface area. How do we do this?
Um,
So work with one face at a time, okay? Let's do the front face. What's the area of a front face? It's a triangle.
7 times 7 divided by 2.
Yes, 7 times 7 divided by 2. That's the front face. And notice there's 2 of them. So I'm going to multiply this by 2, right?
Mm-hmm.
For the front and the back. And then the 2's cancel out. Yeah?
Uh-huh.
Plus, what's the area of this face here? The rectangle that's on the side.
7 times 8.
Yeah, 7 times 8. Plus, what about this side here? The roof.
9.9 times 8.
Yes, 9.9 times 8. That's also a rectangle. What about the bottom, the base of this?
It's also 7 times 8.
Yeah, that's right. 7 times 8. And there we go. That's the entire answer for this question. So 7 times 7 plus 7 times 8 plus 9.9 times 8 plus 7 times 8. That is 240.2 inches squared. Okay, that's a surface area. Now let's look at the volume. If we're looking at the volume, what would be the base area here?
The triangle?
Right, so the volume is the base area times the height, yeah?
Mm-hmm.
Base area. So the base area, we had it before, that's just 7 times 7 divided by 2, and the height is 8, yeah?
Mm-hmm.
So 7 times 7 times 8 divided by 2, and that is 196 inches cubed for the final answer.
Okay.
Cool?
Mm-hmm.
It's fun, yeah? Or no?
Maybe.
Maybe? All right, I'll take the maybe. I'm trying to find some more dicey questions. I guess we can do this one. I'm gonna give you these because this is not part of the plan. I mean, eventually you'll remember them, but we can just give it here. So this question is asking us for the volume of each solid. They're strictly asking us for the volume. But if you were to find the surface area, how many faces does this thing have? So here, let's just count the faces. Okay, surface area is pretty simple. So there's one here, yeah?
Mm-hmm.
There's one here, there's 2 here, there's 3 here, there's 4 here, right?
Mm-hmm.
And then we can kind of do this because we don't know, this is like a Tetris shaped. We don't have a formula for that, but we can cut it off into 2 different things. There's 5 here, there's 6 here, right?
Mm-hmm.
That means on this side, there's gonna be the same thing, the 5 and the 6, except it's gonna repeat 7 and the 8. And there's gonna be a rectangle on this side, 9, and then there's gonna be something on the bottom, 10. So there's 10 total faces if you wanna find the surface area. You see it?
Mm-hmm.
That's pretty tedious. And the question is not asking us for surface area, but if it did, we'd have to add up 10 different rectangles, basically. How would we find the volume of this? And the idea is very, very similar. We need to cut this. We can first find the volume of this, okay?
Mm-hmm.
And then we can add with the volume on the top. What's the formula for the volume of a rectangular prism?
Length times width times length.
Oh, well, height, yeah? LWH,
Oh,
LWH.
okay.
So if we're looking at the prism on the bottom, we know its length is 1 meters, yeah?
Mhm.
What is the width of this shape? on the bottom?
30.
30, but notice that's in centimeters. How do you convert centimeters to meters?
I don't know.
You divide by 100.
Okay.
To go from centimeters to meters, you divide by 100. So 30 divided by 100 is 0.3 meters. Now, what's the height of this guy that's on the bottom?
20.
20? Nope. Look at this. It's not 20.
25.
Nope, 25 is the height for the one on the top. The whole thing is 40, yeah? The height for the top part is 25. Or it'll be the height for the bottom part.
Oh,
15, right?
Mhm.
40 minus 25. And what's 15 centimeters in meters?
0.15.
Yeah, 0.15. Like that. Cool. So that's the volume of the bottom part. What about the top part? Now we're looking at this chunk on the top. What is its volume? What do you think? What's the length? What is this part? The whole thing is 1 meters. From here to here is 60. So what's that?
0.4 meters.
Yes, 0.4 meters. What about this?
0.3.
Yes. What about the height?
25.
Yes, which is 0.25, yeah, in meters.
Mm-hmm.
And there we go. And we're just going to add all of them up. 1 times 0.3 times 0.15 plus 0.4 times 0.3 times 0.25. So the answer for this question is 1.075 meters cubed, okay? Like that.
Okay.
Let me ask you something. How many centimeters is this?
You just multiply it by 100.
Okay, now it's not that easy. That was not a fair question because now it's no longer meters, okay? Now it's meters cubed. And you probably won't have to do this for a long time, but I'm going to show you anyways. So yeah, if it was 1.075 meters, you want to turn this into centimeters. Here's the conversion factor. You got to multiply it by this. You want to kill off the meters. So meters is going to be in the denominator. You want to introduce centimeters because that's what we want the answer in. And the conversion factor is for every 100 centimeters, there's 1 meters, okay? So boom, boom, this cancels out, yeah? So you get 107.5 centimeters. Now that is if it was meters, okay? Now look at this one. Now when you introduce meters cubed, things get a little bit dicier. Now we have a meters cubed there. We want to kill that off. We got to introduce a meters cubed down here, correct? And we want the answer to be in centimeters cubed. Now, what's the conversion factor between centimeters and meters? It's the same thing as we had before, but now we got to put it in a bracket like that. So you're actually multiplying this by 100 3 different times. So you're actually multiplying it by 1,000,000. 1.075 times 100 cubed. It'll be 1,000,000 in the centimeters cubed. because of this cubed element. If it was squared, we wanted the area, then we would just square this. You'd multiply it by 100 twice, okay? So when there's an exponent, things get it gets a little bit more difficult. Uh, hmm. Again, the question is to find the volume of this. The volume is always going to be more difficult than surface area, I think. Again, this shape is a mumbo jumbo shape. It's made up of multiple things. We're going to cut it in half. And that is going to give us what?
A triangle.
Yeah, it's going to give us a triangular prism, and it's going to give us a rectangular prism. Let's find the volume of the left shape here, the rectangle. What will be the volume of that?
Um, $13 times 7 times 10.
No. The length is already, it's not going to be 13.
Oh.
So this one, right? It's just 10. Yeah. 10 is the length. What's the width? Width looks like it's 5, and the height is certainly 7. So that is for the rectangular prism, okay? Now to find the volume of this triangular prism chunk here, we need to first find the base area. What's the height of this triangle?
7.
7. What is the base of this triangle? Notice the entire thing is 13, and up until here it's 10.
So 3.
Correct. It's 3 centimeters. Right? So how do we find the volume of that triangular prism?
You multiply those and put it over 2.
Yes, so 3 times 7 over 2, that's the base area, yeah? Base times height divided by 2. And what's the height of the triangular prism? I mean, it's either 7 or 5.
It's 7.
No, 7 is the height of the base, okay? You see, we're trying to find this height. Because our base is that triangle, our base is that triangle. So it's gonna stand up like this, right? Something like that. And our height is gonna be this one. So our height for the triangle there, or for the prism there, it's 5. The height for the triangle is 7, but the height for the prism is 5, okay?
Okay.
And there we go. And then we just want to plug that in the calculator. 10 times 5 times 7 plus 21 times 5 divided by 2. So the answer is 402.5 cm cubed. Cool. Here's a question for you. Which one will be bigger, the surface area or the volume?
The volume.
Okay, any ideas why that is?
Because it's everything on the inside.
All right, I mean, so that one, it depends on the shape. That was whatever question. No, volume doesn't always win. You'd expect it to win because it's cubed, yeah? But volume doesn't always win. Like for example, look at this. This is a cube, okay? It's a cube. Length is 1, height is 1, and the width is 1. The volume would just be 1 times 1 times 1. It's 1, right? Now look at the surface area. It's 1 times 1. but you're gonna do that 6 times. So 6, you see? Volume doesn't always win.
Huh?
Kind of depends on the dimensions of the shape that's been given. So that was C. I mean, D is pretty simple. We've done that. Let's try this one. D and E are just cylinders, yeah? The volume is just gonna be base area times height. So pi r squared times h. Let's look at this one. So now we have a sphere. A sphere is a circle in 3 dimensions. What is the volume of a sphere?
Um, 4/3 times pi radius square.
Yeah, pi and radius is 7, right? Squared. So 4/3 times 49 pi, and whatever that is, okay? You can just leave it as that, or you can do, what's 49 times 4? Without a calc, you remember how we did that? 49 times 4, that's 50 minus 1 times 4, yeah?
Mhm.
50 times 4 is 200, 1 times 4 is 4, so it's 196 pi over 3, final answer. Or you can plug it in the calculator, but this is the exact value.
Okay.
So that's a sphere, okay? That's a sphere. We haven't encountered a cone yet, but I'm sure we will. Ooh, what about this one? They want us to find the volume of a hemisphere. What is a hemisphere?
Is it half of a sphere?
It is half of a sphere, exactly. What will be the volume of a hemisphere?
Um, the area of the circle and then the diameter.
So the question is, what's the volume of a hemisphere, right? A hemisphere is half of a sphere. So the volume will be this divided by 2.
Mm-hmm.
The volume of an entire sphere divided by a 2. What if I asked you, what's the volume of a quarter sphere? How do we do that?
You divide it by 4.
Yeah, you divide it by 4. So 9 times 4 is 36. 36 over 3 is 12. So we have 12 pi divided by 2, and that's going to be 6 pi. And
Wait,
that's,
is the volume like pi r cubed or squared?
you're right, it's actually pi r cubed. It's not squared. So what'll that be? Well, this is going to make this a squared. So 9 times 4, 36 pi divided by 2, that should be 18 pi. And that'll be the final answer for this question. Yeah, it's a cube. It's a cubed. Okay.
Mm-hmm.
All right, so that's a hemisphere. Let's look at a cone, like an ice cream cone. Right, what's the volume of this shape?
1/3 times pi radius squared times height.
What's the radius?
3.5.
Yeah, 3.5 squared, and then the height is 8, yeah?
Mm-hmm.
Now this one won't be exact, would it? We'll do this times pi times 3.5 squared times 8. So that is 102.63. Let's try finding the surface area of the shape. So that was the volume, okay? What about the surface area?
Pi times radius times length.
Okay, what's the length? The radius is 3.5. What does the length represent?
The diameter, so 7.
No, length is not the diameter. Length is something called the slant height, okay? It's in fact the hypotenuse. Look at this. In this cone, 8 is the height, yeah? Makes a right angle. And we know the radius is 3.5. If the bottom is 3.5, if the height is 8, what's the hypotenuse? We need to find the hypotenuse of that triangle. That is L. That's what L represents. So how do we find the hypotenuse?
You square the numbers and then add them.
Okay, I'm gonna square them and add them. So 8 squared plus 3.5 squared. That gives me 76.25. Is that right?
You have to square root it.
All right, let's square root that, and that gives me 8.73. And there you go. That's what L is, okay? L is the slant height. So times 8.73 plus pi, and then R is 3.5 squared. And there we go, okay? 5 times 8.73 plus pi times 3.5 squared. And the answer is 134.48 centimeters squared. And it's squared because it's an area, surface area, same thing.
Okay.
Cuboid is just another word for a rectangular prism. It's not a cube, it's a cuboid. So they've given us the width, they've given us the height, and they've given us the volume. Question is, what is its length? Any ideas on how we would approach this?
Is this an equation?
Yes, it is going to be an equation. It is certainly going to be an equation.
So 9.5 times 8 times L equals 1292.
That's perfect. Yeah, 9.5 times 8 times L equals 1292. How do we solve this equation for L?
You divide by 9.5.
Yes, so we have 8 times this. I can divide that by 9.5. 129 divided by 9.5, 136. And then?
And then you divide by 8.
Yeah, good. That will be 17. Therefore, the length is 17 centimeters.
Okay.
That wasn't so hard. This one's also going to be an equation. So we have a triangular prism, right? How do you know it's a triangular prism? Because the bases are triangles, okay? In fact, again, think about it. If you chop it in half, what face do you get? That defines what kind of a prism it is. This one, if we chop it, it's going to give us a triangle. And don't chop it this way, because if you chop it this way, if you put a knife this way, okay, it's not going to cut in half, okay? Cross-sectional means it has to be cut in half. That's why we can't like slice this away, because the bottom part would have a bigger area than the top, okay? And the formula for the volume of a triangular prism is base area. So 13 times h divided by 2 times the height of the prism, 16.
Mm-hmm.
And we do know the volume. In fact, the volume is 1768. Question is, how do we solve for h? We're trying to solve this. Again, it's a linear equation, nothing too fancy happening. We want to know what h is.
Do you turn 16 into a fraction?
No, you don't have to do that. Step 1, you see this 2? It's
Mm-hmm.
being divided. We can multiply by 2 on both sides. Yeah?
Uh-huh.
You see the 16, it's being multiplied. We can divide by 16 on both sides. You see this 13, it's being multiplied with h. What do we do on both sides?
You divide it?
Yeah, you divide it. So if you divide it, it's going to come in the denominator here like that.
Mm-hmm.
Okay. So it's just going to be 2 times 1768. And now here, if you're going to plug it in a calculator, be careful. You have to put the denominator in a bracket. So you have to do 2 times this divided by this in a bracket. And that'll give us h is 17, what is it, centimeters. And that'll be the height of the prism here.
Mm-hmm.
Cool?
Uh-huh.
Cool, cool. All right. Woohoo. Now this one, it requires you to simplify algebraic expressions. I do not think we need the formula sheet. I'm just going to put it up here. So in this case, they've given us everything, but it's in terms of x. And the question is to find the volume in terms of x. So let me set this up. So the volume of a rectangular prism, what's the formula? Not a rectangle, sorry, triangular prism, because there's a triangle here. Cut this in half, you'll get a triangle as a cross section.
Base area times height?
Right? So what'll be the base area here? Again, remember it's a triangular prism.
Um,
Any ideas? Here, let me set this up. So the base area here is a triangle, yes?
mm-hmm.
The area of a triangle is base, which is 2x plus 1 times the height, x divided by 2, right?
Uh-huh.
Base, and what's the height of the prism? It's x plus 8, like that.
Mm-hmm.
Now, do you remember how to multiply variables? What is 2x times x?
3x?
No, it's not. Try again. 2x plus x is 3x, not 2x times x. 2x times x is 2x squared.
Oh.
What's 1 times x? That's just ax, okay? So when we multiply these two, we get 2x squared over x over 2. Now we're going to multiply this guy. Because 2 times 1 is just a 2, so you can ignore the 1. Look at this. What is 2x squared times x?
Um,
2x squared times x.
2x cubed.
Yeah, good. 2x cubed. Now next, 2x squared times 8. 2x squared times 8.
Um,
It'll be 16x squared.
okay.
Okay, 16x squared. What is x times x?
X squared.
Yes. What's x times 8?
8x.
8x, there we go. All over 2. Are there any like terms in the numerator?
Um,
Can we add anything up?
the
Yes.
16x squared and x squared.
Yeah, exactly. So you get 17x squared plus 8x over 2. Okay, like that. And that'll be the final answer. And the units is centimeters cubed. There we go. Final answer in terms of x.
Okay.
Okay, so it doesn't matter what x is. We can just plug x as 5 or something in here to get the final volume. Okay, this one should be interesting as well. The diagram shows the area of each 3 faces of a cuboid, which is just a rectangular prism. The length, they are in whole numbers. Find the volume. Ooh, very, very interesting. Now, if they asked us for surface area, this problem would be very simple. We just add all of them up and double them, right?
Mm-hmm.
But they are not asking us for the surface area. They're asking us for the volume. And this is where you have to kind of think outside the box. And whenever there's something that's unknown, like in this case, we don't know what the length is, we don't know anything, yeah? We're gonna put some letters onto this. You see, this is L, this is
Mm-hmm.
W, this is H. Can you tell me what is 12 equals to?
H times L.
Yes, we can call it LH. So L is gonna be 12 over H, yeah?
Mm-hmm.
Can you tell me what 10 is equals to?
H times W.
Right, H times W, yeah?
Mm-hmm.
Actually, let me write down everything in terms of H. So H is gonna be 12 over L from the top, and here H is gonna be 10 over W, yeah?
Mm-hmm.
What about from the top equation? What's 30 equals to?
W times L.
Yes, LW, okay? So L is 30 over W. All right,
Mm-hmm.
write everything in terms of its equation and isolate for one of them. Now look at this. This is H and this is also H, right?
Mm-hmm.
They both represent H. So we're gonna make an equation. 12 over L is equals to 10 over W, like that.
Uh-huh.
Good so far?
Mm-hmm.
Now what is L in terms of W? Look at the third equation. L is 30 divided by W, yeah?
Mm-hmm.
So you have 12 divided by 30 over W is equals to 10 over W, like that, right? 12 divided by L or 12 divided by 30 over W, which is the same thing as 12 times W over 30 is equals to 10 over W. There we go. We get a linear equation with one variable, and that we can solve. How do we solve that equation for W?
Do you multiply both sides by 30?
Sure, let's do that. So we get 12W is equals to 300 over W. What's next? What do you do when the unknown is in the denominator?
You multiply it?
You multiply both sides by the denominator. What's 12W times W?
12W squared.
Yes, good. 12W squared. There we go. How do we solve this equation for W?
You divide by 12.
Yes. 300 divided by 12, and that is 25. So W squared is equals to 25. Now what?
You square root it and get 5.
Yeah, exactly. So W is 5, right? That means H is 10 over W, so 10 over 5. H is 5, yeah? Or sorry, H is 2. And then L was 30 over W, 30 over W, and W we found was 5. So therefore the length is 6. And there we go. That's going to be the final answer.
Okay.
Okay, so this one required us to kind of play around with 3 different equations. It's a quick question for you. Let's say 3x squared times 4x3. What do you get? I'll give you options: 7x5, 12x5, 12x6, or 12.
6.
So no, that's not right. This is the right answer, okay? Basically, when you multiply the exponents, you see this? XS2, XS3, you're supposed to add them up. And when you're dividing, you subtract them. Okay?
Okay.
And the numbers, you can just treat them independently. 3 times 4 would be a 12. The numbers don't really matter. But the letters, the variables, if they have exponents, you need to add them up, okay?
Okay.
All right, let's call it there for today.
All right. Thank you.
Bye-bye.